Hello guys, so I'm not in today, but I still want to teach you because like I said, we are rushing syllabus. There are a lot of things that we need to cover before the when we come back in term 2. So every class is important. So today I'm not in because I have to attend a meeting to with Cambridge, UK Cambridge, because I'm marking the May-June exam for papers for maths. So yeah, so that's why I need to be away, okay, and I cannot teach you, but it's okay. All right, life goes on, we will still learn. All right, I can still teach you through videos, so let's learn from here. Okay, now let's turn to page number 89 of the workbook. Now let's take out a workbook and turn to page 89 now. Hurry up. Okay, I'm gonna give you a few seconds to open to the page 89. Page 89, chapter 4. Alright, so there. Now in this chapter here, right, okay, we are talking about equation, inequalities and graphs. So basically, right, okay, in this chapter we are talking about drawing graphs. So I do know that we have learned about drawing graph before, but specifically here we are talking about drawing modulus graph for linear form, quadratic form and cubic form. Okay, so we will go for linear first. So basically when I say linear form means that you have to know that we are talking about y equals to mx plus c graph, right? Straight line graph. So but of course we are talking about modulus, or another word we call as absolute value. Now what does it mean by absolute value? You will see absolute value when we have these two lines. I think we have seen it before when we do the shoelace method to calculate the area of a triangle or the shapes. Remember the shoelace method, right? So today, right, we are looking at the modulus x. What does it mean is that modulus means that any number inside that is positive or negative will come out as positive. For example, if I have modulus of 4, it will give me equals to 4. Okay, all right. So or maybe, right, if I have modulus of negative 4, because it's negative inside, it will also come out as 4, right? So it will be 4 also. Okay, so it doesn't matter what value inside, positive, negative, the result come out will always be positive. That's what absolute value mean, right? In another word, right, you will see me calling this thing a lot of time as modulus. So it's the same meaning. Okay, all right. So now the first thing I want to talk about, right, is solving modulus equation in linear form first. We're talking about linear form. So let's this question, right, okay, they want to solve this modulus x minus 5 equals to modulus of x plus 1. I want to solve it algebraically and also draw it using graphs. So we also need to know how to draw graphs. Okay, now every time I like to use, there's a lot of method of doing this kind of question, but I like to use the squaring method, because squaring method, right, works for everything. Every single thing also works. Okay, now because, right, when you have modulus inside this part here, right, this x minus 5 here, it can be positive or negative, right? Because modulus, I told you, if it's positive you still get positive, negative you still get negative. So which means that inside here, the x minus 5 here or the x plus 1 here, right, can be positive or negative. But I don't want that, because if it's positive, negative, there are two possibilities. It's very hard for us to solve it, correct? But the moment I square both sides, let's say I square here and square here, anything that is inside I square, right, will always give me positive also. Like for example, right, I have positive 2, I square it, I get 4. When I have negative 2, I square it, I will also get 4, positive 4. So meaning to say, right, I don't care already. The moment I square it, right, whatever inside, positive or negative, the result that I get will also give me positive. So it's fine. Correct? So that's why, right, I square both sides, so that it will always be positive. We are looking at the positive region part. Okay? So when I square both sides, means I'm writing x minus 5 square equals to x plus 1 square. I square both sides. It becomes like this. Okay? So remember, we learned when we square open bracket for this question here like that, there are 3 terms coming out from it. We have x squared minus 10x plus 25. Remember, square the front, all 3 multiply together, square the back. Okay, then it's equals to x squared plus 2x plus 1. Okay? So then, right, you rearrange, you get negative, this x squared minus x squared disappear already, no more already, 0. So the 2x you bring over, so it's negative 12x equals to 1 minus 25. So you have negative 12x equals to negative 24. Then x is equals to 2. That's the solution that we are talking about. Okay? Alright? So that is how we solve it algebraically. Okay? Every time also the same. We will always write square both sides. Then it will be easy. But of course, there's another method of doing things. I will show you next time. There's another method of solving this kind of question without squaring. Okay? But I like to use this method because it works for every time. Okay? Alright? So the answer here is 2. Now, the next one, right, I want to draw the graph. Okay? I want to illustrate in a graph. It's very important because exam, they love to ask graph. Okay? So to draw the graph, I want to see that the answer, whether it's 2 or not. I will separate this equation, right, into 2. One of it is y equals to modulus of x minus 5. That's the one equation here. The other equation I have, right, is y equals to modulus x plus 1. I will draw this graph separately. Okay? Now, we will first, right, need to identify the vertex first. I like this method because sometimes in exam question, right, they give us funny things. So if you don't identify your vertex, right, it's very hard for you to draw. Okay? Now, what is vertex? Vertex is basically talking about a sharp point that we are considering. Like for example, right, if I have a triangle, okay, a triangle, these are all the vertices. This one, you see this dot here, this dot here, the sharp point here, okay, right, this sharp point here, this sharp point here, and this sharp point here. These are all the vertices. This is the vertex. Okay, so I want to determine the vertex, the sharp point of the graph first. Okay, now I just want to recap a bit with you. You remember, right, when we learned about our quadratic equation, I have y equals to x plus a square plus b, remember? Okay, I want to find the minimum point. How to find? Okay, remember the x plus a, if it's plus a, it becomes negative a. Then the b is just b. So when you draw a graph, right, the minimum point is here. This is negative ab, remember? So this is the vertex one. This is how we find the vertex. So using the same method, right, we will also use it to find the vertex for the straight line in this question here like that. Okay? Now you see, right, there is no number here. You plus nothing here. There's empty. There's no number here, 0. That's why, right, your vertex here is actually equivalent to 5. Why 5? Because x minus 5, so it's 5. And there's no number at the back, so it's comma 0. That's the vertex. Okay? So that's why, right, we know that the graph, the purple color graph that I'm going to draw, you will have a 5, 0 as the one of the point. So 1, 2, 3, 4, 5 is here. So I'm going to plot that as 5. Okay, I just plot that as 5 because I need that. So this is 5. Okay, alright. Now, to draw a modulus graph, we will always choose one number on the left and one number on the right. So the first step, right, is to identify the vertex first. Identify the vertex first, okay. Number 2, you will sub, okay, one point on the left, on the right or left doesn't matter lah. Which one doesn't matter, on the left, okay, to the equation. And then number 3, you will sub 1 point on the right. On the right. Okay, it doesn't matter which one comes first, but one left, one right. So we need to say, right, I will choose 1 point from here. I need to choose 1 point from this region here, anywhere here. Because 5 is here, I just want to choose 1 point on the left side. So I will choose x equals 0 because I need it. So what is x equals 0? Let's see. You just put inside here, alright? Maybe I move this thing down. Okay, move this equation down. Now I sub in x equals 0 into the equation. When x equals 0, y is equals to modulus 0 minus 5. So this is modulus of negative 5. which is going to give you 5. Right? Okay, because I told you anything modulus negative become positive. So you will know that this is 5 also. So 1, 2, 3, 4, 5. So the point is now here, 5. Okay? Then right, you will choose another point on the right. So maybe I choose 7. This point here, 7. Okay, so when x equals to 7, so your y is equals to modulus of 7 minus 5, which is equals to modulus of 2, which is equals to 2. So you know that you have a 7, 2. So 7, 2, 6, 7, 2 is here. That's the coordinate that we're talking about. Okay, right? So how then we will just draw. We just join them. This point here, I will join. Sorry, my bad. Straight line. This point here, I just join them. Join as long as possible. I just join the point, right? And this point join here. That's the graph that we are talking about. Okay. See now why the graph is like that? Because I told you everything modulus negative become positive. That's why there's no negative number there. Okay, alright. So the graph will be like that, a V shape. Can I? Okay. So don't forget to label the graph. Every time when we draw graph, we must label the graph also. So the graph here, right, is y equals to modulus x minus 5. Okay. Now let's do the red one now. So same idea. What's the vertex here? The first thing we do. What's the vertex here? Right? There's no number at the back. So x plus 1, you will get what? Okay, what you get? You get negative 1, comma 0. Why negative 1, comma 0? Because there's no number at the back of the modulus there. Okay? Alright, so that's the first thing. So where is negative 1, 0? Negative 1, 0 is here. Correct not? I want to put it negative 1, 0 is here. Okay? Now then you choose a point on the left. Okay? Any point on the left. Any number you like. Maybe I choose negative 4 lah. So when x equals to negative 4, then y is equals to modulus of negative 4 plus 1 is equals to negative modulus of negative 3, which is equals to 3. So negative 4 is 1, 2, 3, 4. Then 1, 2, 3 is here. The point is here. Okay? Then you choose any point on the right. Okay? So I will choose 0. Because right side is here, right? So I choose 0. So x equals 0. I get y equals to modulus 0 plus 1 is equals to 1. So that's why my point is here, which is 1. Okay? Now, why do I always find x equals 0, y equals 0? Because you know that we always draw graph, right? We need to identify the y-intercept and the x-intercept. That's why we always x equals 0, y equals 0. Now, though all this working, right, you don't do also never mind. Because when we mark the graph only. So you must indicate your y-intercept, x-intercept. Okay? So that's why, right, the graph here now, okay, you will just take your ruler and join them. So the graph now looks like this now. Oh, why is it not moving? Hello? It's coming jam, eh? Okay, wait. Let me refresh for a while. Okay, so this graph here now, when we join it, alright, it will look like this now. So this is the line. Okay, and the other line that I have is this line. Okay, so it's a bit hard to see now because of the thing. I don't know why it's always blocking me. Yeah, I cannot use this. I must use shape. And it's always blocking me one. Don't know why. Okay, this is the graph. Okay, so don't forget to label your graph. So this is y equals to modulus x plus 1. Now do you see that the answer that you have is this the point, a cross-section point is 2. This is 2, see not? This point here is 2. that is the answer that you found just now. This is graphical method. Okay? Can? Alright? Now, the graph, right, sometimes they don't give us grid like that. You have to know when to draw cross 2 points and when to cross 1 point. Now, you will only cross 2 points if your gradient, right, are different. Okay? Now, what does it mean? Now, look at this question here. This is x minus 5. Your gradient, right, is 1. mx plus c ma, so gradient is 1. This x plus 1 down here, right, the gradient here is also 1. So if both the gradients the same, they only cross 1 point. If the gradients are different, then they will cross 2 points. And you must draw crossing 2 points. Otherwise, right, your answer will be wrong. Okay? So in this case, right, m equals to 1 and m equals to 1, they are the same number, they will cross 1 point only. That's why the graph cross 1 point only. Now, even though, right, because it's modulus, even though, right, if let's say I have equation y equals to modulus x plus 1, and the other one, right, is y equals to modulus 2 minus x, okay? The gradient here, I know is 1. The gradient here, right, I know is negative 1. Now, because it's modulus, it doesn't matter. As long as the number is the same, they will also cross 1 time only. Alright? The number the same, but one positive, one negative is still fine. They will still cross 1 point. Okay? They will only cross 2 points, alright? If and only if the numbers are different, then they will cross 2 times. Okay? Alright? So this is the thing. Okay? Right? Now let's look at question number 2. Right? I want to solve this equation algebraically. So our steps the same. So first thing first, I will square both sides. So 2x plus 1 square, okay, equals to x minus 3 square. I will square both sides. Okay? Then we'll expand. It give you 4x square plus 4x plus 1. Then equals to x square plus minus 6x, is it? Plus 9. Alright? Okay? And then I will bring it over. I have 3x squared. Then this is plus 10x minus 8 equals to 0. Alright? Then we will solve this thing by expansion. Okay? We will solve this thing by factorization. So what you get? 3x, then x, then maybe this is 4, this is 2, this is a plus, this is a minus, equals to 0. So that's why your x, right, is equals to 2 over 3, and x is equals to negative 4. So you see there's 2 answers. Why is there 2 answers? Why are there 2 answers? Because the gradient. You see, this gradient, this equation, the gradient is 2. This equation, the gradient is 1. mx plus c. Okay? So since the gradients are different, I told you when the gradient different, then they will cross twice. So when they cross twice, they intersect twice. That's why you have 2 answers. Okay? Right? So when we draw our graph now, right, we will expect that it will cross 2 times. Okay? And you must also make sure that they cross 2 times. Because in exam, right, if I give you 2 equations of different gradient, you only cross 1 point 1 time, then I will still mark you wrong. You have to know yourself. Okay? Now let's draw the graph now. So I have 2 equations. So 1 equals to 2x plus 1, right, modulus. The other one, right, I want to put it as red, is equals to modulus of x minus 3. Okay? Now I want to find the vertex first. So that's the first thing we do. The vertex here, right? What is the vertex here? What do you think? 2x plus 1. So the vertex is negative 1 over 2. Now, Kai Xuan must be asking, why is it negative 1 over 2? Because 2x plus 1 equals to 0. So 2x equals to negative 1. X equals to negative 1 over 2. That's why it's negative 1 over 2. Okay? Then there's no number outside, so it's comma 0. So that's the answer. That's the vertex. Okay? So we know that the point now we are talking about is here now. Negative 1 over 2 is here. It's somewhere around here. Okay? Then what are you going to do? Then you will choose one point on the left and one point on the right. Any point you like. So I want left, maybe I choose negative 3, right? Because I want it to be on the left side. So left side, let's say I choose negative 3. So when I choose negative 3 means x equals to negative 3. So y is equals to modulus of 2 times negative 3 plus 1. Modulus, I have modulus negative 6 plus 1. I have modulus of negative 5, which is going to give me 5. Okay? So negative 3, 5. So 1, 2, 3, 5. 1, 2, 3, 4, 5. So somewhere around here. Is it? 3, 4, 5, 3. Yeah. So that's the point that we're talking about on the left side. Okay? Right. Then you choose one point on the right side. So any point on the right side, maybe you have to choose 0 because I need the point. So when x equals 0, I will have modulus of 2 times 0 plus 1. I will have y equals to 1. Just 1. So that's why it's just here. 1. Okay? Right? Now this step, right, like I said, if you don't want to do right, it's fine. It's fine one. You just mentally do it also can. Because I only mark the graph. So then you will take your ruler. Okay, ruler and then draw the graph. So this is the graph that I'm talking about. This is the line. And the other line that is going to be like this. It's joined here. So this is the graph. Don't forget to label y equals to modulus 2x plus 1. Okay? Now, the red one on the other hand, now what's the vertex here? The first step. The vertex here is 3, 0. So this is a point here. 1, 2, 3 is here. 0. Okay? Then you choose any point on the left side. I choose 0, so I need it. So when x equals 0, y equals to modulus 0 minus 3. So it gives you 3 only. Because modulus negative 3, it will give you 3. So this is going to be 1, 2, 3 is somewhere around here. So label 3. And I will choose one point on the right side. So since that this is 3, I'll choose one number. Maybe I choose 5, up to you. Right? So when x equals to 5, y is equals to modulus 5 minus 3, you get 2. So 5, 2 is here. Okay? Right? Then you will just take a ruler and join them together. So shape, this is a ruler, this is a line. The things keep blocking me always. This one is like the line here. Okay? Right? So you see, there are 2 crossing points. One of it is your answer, negative 4, you see? Negative 4 is here. And the other one is at 2 over 3, so somewhere around there. So you have 2 crossing points. Reason being because the gradients are different. That's why you have 2 crossing points. Can? Alright? So that is this answer. Okay? Now, like I said, later I do one question without doing all these things. We will just quickly run through the questions, okay? Can Alright, now next one, question C. I want to solve it algebraically first, so I need to square it. So like I told you, when we square it, both sides also need to be squared. So let's square both sides. So I square both sides, I have 2 minus x squared equals to 5 also need to square, bracket 1 over 2x plus 1 squared. You also square this side. So both sides must be squared. Okay? So here, you open bracket, you get 4 minus 4x plus x squared equals to 25, bracket 1 over 4x squared, okay, plus x plus 1. Okay? And then what's the next step? Right, we expand. Okay, I arrange it properly so you can easily see. So x squared minus 4x plus 4. Okay, and then is equivalent to 25 over 4x squared plus 25x plus 25. Okay, open bracket. Okay, then because of the 4, the denominator 4, I multiply everyone by 4. So I have 4x squared minus 16x plus 16 equals to 25x power to 2 square plus 100x plus 100 because I times 4 for everyone. I want to remove the 4. Okay, then I rearrange. I get 21x power to 21x squared, then plus with 116x, then plus with 84. I bring everything to the one side so that it's equals to 0. So I can solve this equation. Alright, okay, so you need to factorize this equation now. So you can either use your calculator or you can think about it yourself. But I'm going to ask my best friend. Okay, I'm going to ask ChatGPT how for the answer. So ChatGPT for the answer. So you try to factorize yourself. Let me log in first. ChatGPT in. Go. Okay, I want to solve 21x power to 2, then plus with plus is where's the plus? Where's the plus sign? There's no plus sign? Oh yeah, plus with 116x plus with 116x minus, is it? No, plus with 84. So plus with 84 equals to 0. Okay, according to ChatGPT, the answer given to us is, wait, solving. So of course in exam, right, okay, the number won't be so big lah, right? It will be a nicer number in which you can factorize easily. So here is just an example. So that's why it's a bit difficult. So the answer given to us is negative 6 over 7. So which means that I have 6 over 7. So 7x plus 6, right? And the other one I have is negative 14 over 3. So it's 3x plus 14 equals to 0. Okay, so my x is equals to negative 6 over 7, or my x equals to negative 14 over 3. So there's two answers here. Okay, so again, if you look at the gradient, this equation here has a gradient of negative 1. This equation has a gradient of 1 over 2. Now because the gradient are different, so that's why we have expect there are two intersection point. So there will be two answers. That's why we have two answers. Okay, that's why you have two answers here. Okay, so now let's draw the graph. So let's do one by one. Y equals to modulus of 2 minus x first. So the vertex is what? What's the vertex here? It's 2, 0. Okay, so y20 again, we say, let me refresh first because jam already. Oh no, why faster lah? Okay, right. So y20 because 2 minus x equals to 0, negative x equals to negative 2, then x equals to 2. That's why it's 2, 0. Okay, so your vertex here is 2, 0, which is this point. Okay, now I don't want to write so many things. We're going to straight away do. I will choose one point on the left side, so I choose x equals 0. So when x equals 0 means 2 minus 0 is 2. Modulus 2 is 2. So answer is 2. Okay, you can think of it like that. Just sub in yourself. 2 minus 0 is 2. So modulus of 2 is 2. That's why your answer here is 2. So this is 2. This is also 2. Okay, Then you will choose a number on the right side. Maybe I choose 5. So 2 minus 5 is negative 3. I put 5 inside. 2 minus 5 is negative 3. So modulus of negative 3 is 3. So 5 is 3. So 5 is 1, 2, 3. So it's here. That's the point. Okay? That's why, right, when I draw the graph will look like this now. This is my point. The other one is like that. I think it's like this. Yeah. So don't forget to label your graph. Draw longer. It's okay to draw the whole graph. Draw longer. So because sometimes, right, you must make sure that they cross. So this is y equals to modulus of 2 minus x graph. Okay. Now the next one we draw, right, is y equals to 5 modulus 1 over 2x plus 1 modulus. Okay. So how are we going to do this? What is the vertex here? Right, the 5 have no effect on us. So the vertex here, right, is just 2. Again, why is it 2? Because 1 over 2x plus 1 equals to 0. Oh no, not 2 negative 2, sorry. Negative 2, I bet. Okay, so because 1 over 2x plus 1 equals to 0, then 1 over 2x equals to negative 1, then x equals to negative 2. That's why negative 2, 0 is your coordinate. Okay, so that's why your point here is negative 2, 0, so it's here. Okay, right? So you will choose one point on the right and one point on the left. So let's say I will choose maybe negative 4. Okay, I will choose even number because of the half. So I choose an even number. So negative 4. So let's say x equals negative 4. So you just sub inside. 1 over 2 times negative 4 is negative 2. Negative 2 plus 1 is negative 1. So modulus of negative 1 will give you 1. Right? 1 times 5. Don't forget the 5 is 5. So your y is equals to 5. I say again. 1 over 2 times negative 4 is negative 2. Negative 2 plus 1 is negative 1. So modulus of negative 1 is 1. And 1 times 5 is 5. That's why it's 5. Okay? So you have to think of it like that. Because, right, eventually we don't want to waste time writing it down. You have to look at it straight away, do mental maths. Okay? So here, right, you have negative 4 and 5. So 1, 2, 3, 4, 5. So it's somewhere around here. Okay? Then we will choose a point on the right side. So maybe I have to choose x equals 0 because I need it. Like I said, I need it. So x equals 0. So when x equals 0, half times 0 is 0. 0 plus 1 is 1. So modulus of 1 is still 1. Times 5, you get 5 also. So it's 0, 5. So it's somewhere around here. So this is 5. Now every time your graph crosses the y-intercept and the x-intercept, you must indicate. Okay? So then you draw the graph lah. So you take the shape, right? And then you will draw the graph. This graph is like that. From here to here. And then from here to here. You see, they will cross 2 times. Now, important thing is that in drawing this kind of like modulus graph, you need to indicate that you cross how many times. Different gradient twice. Okay? So don't forget to label your graph again. Right? So remember to always label your graph because examiner have no idea which graph you're talking about. Okay? Which graph is referring to which one. So always remember to label your graph. Okay? Yeah? Right, so that's the answer for this question here. So it's always like that. Okay? So the step to draw graph is always the same thing. Determine the vertex first. Then substitute one point on the left, one point on the right. Then just draw the graph. Okay? Now, if you can straight away draw, by all means do that. But this is one of the easiest way I can think of to actually guide you with this kind of questions. Okay? Algebraically solve, you square both sides. Then you solve. Drawing graph, always the same step. Identify the vertex, sub one point like that. Okay? Can? Now I want to show you another question. How determining the vertex, right, is important for us. Now let's turn to page number 116, 100 and something, 116, yeah. There's a blank page there. Okay, at the page 116, there's a blank page. Okay, now let's say I want to draw a graph y equals to modulus 2x minus 1, right, minus 3, let's say. I want to draw this graph now. Okay, all right. So now, first thing first, we need to determine the vertex. That's what we're going to do all the time, correct? We determine the vertex. So what's the vertex here? Okay, what's the vertex here? The vertex here is 1 over 2 comma negative 3 because of the minus 3. So when I draw my graph, right, let's say this is the graph that I want to draw. Let me use the shape. This is the line. This is the line. Okay. And this is the y-axis. This is the x-axis. The x-axis, y-axis. So this is the y-axis. This is the x-axis. Right? Now my point now is at 1 over 2 negative 3. So 1 over 2 negative 3 is somewhere around here. Here. Where this is negative 3. This is 1 over 2. So this is the vertex. Okay? Alright? Now, because now I want to find the y-intercept, x-intercept, so I will need to find the x equals 0 and y equals 0 because I need the y-intercept and x-intercept. So when x is equals to 0, your y is equals to modulus of 2 times 0 minus 1 equals minus 3. So this is 2 minus 0 minus negative 1. So modulus negative 1 minus 3. So this is 1 minus 3 is equals to negative 2. So we know that it will cross negative 2 here, somewhere around here. Negative 2. Okay? And we also need to know the y-intercept. So y is equals to 0. So we have 0 equals to modulus 2x minus 1. Modulus minus 3. Then you bring over, you have 3 equals to modulus 2x minus 1. Modulus, correct not? So like I said, I like to use the method of squaring, but there's another way of doing it. So let's square lah. Let's square both sides. So 9 equals to, I square both sides. I square both sides. So I have 9 equals to 4x squared minus 4x plus 1. Then I have 4x squared minus 4x minus 8 equals to 0. Then I divide everyone by 4. I have x squared minus 4 minus x minus 2 equals 0. Then I can factorize. 1 equals 0. Then it's minus, this is plus. Correct? So you have x equals to 2 and x equals to negative 1. Okay? So that's why, right, your graph now will look like this. This is your graph. Yeah, sorry, my bad. I should draw using the line shape. This is your graph. The vertex is here. It will cross negative 2 and the other one will cross somewhere around here. So the y-x-intercept, right, is here, which is, yeah, is here, which is negative 1 here. This is negative 1. This is 2. So this is your graph. You see, right? Now, just now I told you, right? Supposingly, there is no negative side of the y one because of the modulus. But because of the minus 3, your graph has dropped down by 3. That's why the whole graph dropped to the negative side. That's why the vertex is here now. So that's why, right, to determine the vertex is very important. Because sometimes, right, the vertex is bottom here. Sometimes it's on top. Depends on the question. So always determine the vertex first. Okay, can? Right, let me show you this question still here so you can copy. But you can also open the Google Classroom, your Google Classroom's file to determine. Okay, so now you can do exercise 1, okay, for the rest of the period. So let's get exercise 1 done. Okay, there are exercise 1, there are only 6 questions, so let's try that. Okay, solve algebraically and then draw the graph. Okay, so that's all for today. So just continue to do exercise 1 until the end of the period. So I'll see you guys on when we come back from holiday. Happy holidays.